Hello, Group 27 here presenting our machine learning project on sleeping disorder detection. To start, a sleeping disorder is a condition that disrupts regular sleep or prevents sufficient amount of normal sleep. A sleeping disorders we're focusing in on our project is insomnia and sleep apnea. This is a problem as sleeping well is critical to overall well-being, yet disorders like insomnia and sleep apnea increase the risks of chronic conditions such as cardiovascular disease, obesity, and mental health issues. Our solution is to analyze key factors and correlations between sleeping and other various demographics, lifestyle, and physiological factors to help inform caretakers, professionals, and individuals to improve their sleep. We plan on investigating on how lifestyle behaviors like exercise and work habits impact the quality of sleep. Identifying these correlations will allow us to provide recommendations for lifestyle changes that may promote better sleep.
Methodology and implementation. Exploratory data analysis is a way of understanding the structure and characteristics of the data, identify how the variables are connected, look for outliers and anomalies, make a hypothesis for future model expansion. We implement EDA by using data visualization, correlation analysis, data distribution, and scale analysis. Data pre-processing allows us to do cleaning, feature scaling, encoding categorical variables, and feature selection or extraction. We use label encoding and one-hot encoding in our project. Label encoding allows you to transform data, such as gender and BMI, into numerical values. One-hot encoding allows us to convert categorical data into binary columns. Our objective is to predict the presence of a sleep disorder. Our problem is a multi-class classification problem, and our target variables are normal, sleep apnea, and insomnia. So therefore, we'll be using random forest classifier. Random forest classifier can handle multi-class problems and nonlinear relationships. This is the best model for this because it has high accuracy, it's versatile, it's more resistant to overfitting, and you can scale it and it will perform well with large data sets. And the evaluation metrics that we're using to see how well our model performs are precision, recall, accuracy, and F1 score. The visualization method that we're using is ROC curves, and the optimization techniques that we're using are grid search and cross-validation.
Next, we'll talk about results. Here are results for label encoding, where we turned these variables from categorical to numerical. Next, we fed them into our correlation graph, and we got to see the positive and negative correlations. Some observations from this were that positively correlated top predictors were sleep duration and quality of sleep. However, negative correlated variables included BMI category, occupation, and blood pressures. Also, we took a look at other variables that were also of significance but of weaker influence. This helped us for feature extraction. Also, we looked at gender distributions to see how the sleep disorders were affected by gender, and we saw that there was quite a difference between male and females, as females were more likely to have normal sleep, and males also had a lot more sleep apnea in general. Next, we looked at the occupation distributions just by gender and also the influence on the sleep disorders. And here we saw significant disparities between the occupations, which doesn't really help us for the model, but does add context for the problem. And we also saw how some professions, such as nurses, seem to have a more likely chance to develop a sleep disorder, which we'll get into why a little bit later on. Next, we looked at the scale of all the variables, and we could see that they were at very different scales. Thus, we normalized the data to make them on a same scale for better ingestion, and the distributions obviously stayed the same. Next, we look at the outliers to see if there was any outliers in the data. There were only really in heart rate, and we decided to keep those in because they may have an effect on the sleep disorders. This brings us to our first iteration of the model. Based on the EDA that we conducted before, we chose these features to include in our model, and we only implemented label encoding. Here are the results for our first model. As you can see, there's fairly good performance. However, occupation is the most highly ranked feature, but since we didn't one-hot encode it, we don't really get much of that in terms of insights. Here are the ROC curves, and we can see that there's different area under the curves for different classes. Which brings us to model version 2. Here we decided to choose more features to include, and we also choose to implement one hot encoding for occupation. Here are our version 2 results, which shows better performance overall and also a shift in the feature importance. Here are ROC curves, which again show improvement in terms of classification by classes and also the micro-average ROC curve. Based on this, we chose to choose version 2 to then optimize, and this would be called version 3. Here are version 3 results, which again show improved results from version 2. The ROC curves improved in all areas, and we can see that the precision, recall, F1 score, and accuracy scores are all higher.
Let's get into some of the key observations that we've made throughout the project. Males showed a higher prevalence of sleep disorders, particularly sleep apnea, while insomnia was more evenly distributed between genders. BMI also played a critical role, with those classified as overweight having the highest rate of sleep disorders. This highlights the close relationship between physical health and sleep quality. Occupation was another notable factor. For example, individuals in the nursing profession were disproportionately affected by sleep disorders. Lastly, we developed some lifestyle recommendations based on our findings. These include practical steps like maintaining a consistent bedtime routine, staying physically active, and managing stress through relaxation techniques. For those with specific risk factors such as high BMI or blood pressure, targeted interventions like dietary adjustments and regular health checkups can make a big difference. Overall, we achieved our goal to build an machine learning model that can accurately analyze and predict sleep-related conditions. Our model had an overall accuracy of 91%, with an exceptional result for insomnia with an F1 score of 0.95 and a 0.84 F1 score for sleep apnea. The feature importance analysis gave us valuable insights as well. For instance, nurses and individuals with higher BMI categories were notably more prone to sleep disorders, which aligns with broader health trends. Focusing on predictors like occupation and physical health metrics helped us uncover actionable insights to guide interventions.